Imagine this. You board a sleek silver spaceship. Destination? Proxima Centauri b, a planet orbiting the closest star to our sun. The engines hum, not with a roar, but a silent, powerful energy. You're about to experience the universe as only a select few ever could at the speed of light. As the countdown reaches 0, you feel a rush, not of acceleration but of something shifting, changing within the very fabric of reality. Welcome to Perspective of AI. You're no longer just traveling through space, you are one with it, moving at a speed so incomprehensible, so fundamental, it's as if the universe itself is holding its breath. The speed of light. It's a concept that has fascinated scientists and laypeople alike for centuries. This speed, often denoted by the letter c, is a fundamental constant in the universe, 299,792,458 meters per second. This staggering number represents the ultimate speed at which information and matter can travel. It's not just a number, it's the law of the cosmos. This speed limit is woven into the very fabric of the universe, dictating the behavior of everything from the smallest particles to the largest galaxies. Nothing, absolutely nothing, can travel faster. This universal speed limit is a boundary that cannot be crossed, no matter how advanced our technology becomes. This speed is more than just how fast light travels. It influences the very nature of reality, affecting how we perceive time and space. It's woven into the very fabric of space and time. The speed of light is a constant that underpins the structure of the universe, shaping the way we understand the cosmos. It dictates how information travels, how energy interacts, even how the universe itself expands. From the transmission of data through fiber optic cables to the propagation of electromagnetic waves, the speed of light is a fundamental limit. Think of it like the ultimate speed limit in the universe. Just as speed limits on roads ensure safety and order, the speed of light maintains the structure and coherence of the cosmos. Even the fastest rocket we can imagine is a snail compared to a beam of light. The vast distances in space make the speed of light a crucial factor in our understanding of the universe. It's this cosmic speed limit that makes our journey to Proxima Centauri b so remarkable, so impossible according to the laws of physics as we know them. The speed of light is not just a barrier but a gateway to understanding the true nature of the universe. Now, our bodies aren't designed for such speeds. If we were to accelerate to even a fraction of the speed of light, the g-forces would be crushing. Imagine the pressure of 1,000 suns pushing down on you. That's the kind of force we're talking about. But let's say for the sake of our journey that our spaceship has some kind of magical technology that shields us from these effects. What else would we experience? Even then, the very atoms that make up our bodies would be vibrating at an unimaginable rate. It's a good thing we're just imagining this because the reality would be far from comfortable. Section 4. Seeing the universe in fast forward. But the most dramatic change would be to our senses, especially sight. Our eyes, which are accustomed to perceiving the world at a relatively slow pace, would be overwhelmed by the sheer speed at which light and colors would change. As we approach the speed of light, the colors of the universe would start to bleed into each other, a dazzling, psychedelic light show. The stars and galaxies would transform into vibrant streaks of light, creating a surreal and mesmerizing visual experience. This happens because light itself is affected by our speed. The faster we move, the more the light waves compress or stretch, altering their appearance dramatically. Imagine running alongside a beam of light. It would seem as if the light is slowing down, almost as if time itself is bending to accommodate our incredible speed. It would appear to slow down, maybe even stop from your perspective. But that's not all. The very fabric of space and time would seem to warp around us, creating an almost dreamlike state of existence. The light from stars ahead of us would get compressed, making them appear bluer. This phenomenon, known as blue shifting, occurs because the wavelengths of light are shortened as we move towards the source. The light from stars behind us would stretch out, making them appear redder. This is called red shifting, where the wavelengths of light are elongated as we move away from the source. This is called the Doppler effect, and it's not just a theory. We observe it right here on Earth with sound waves. For instance, the change in pitch of a passing siren is a common example of the Doppler effect in action. In space, this effect is magnified to an extraordinary degree, altering not just sound but the very light that reaches our eyes. The universe in fast forward becomes a symphony of shifting colors and bending light, a testament to the incredible nature of our cosmos. Section 5. Time warps at the speed of light. And then there's time. Time, as we perceive it, is a constant, ticking away second by second, minute by minute. But what if I told you that this perception is merely an illusion? Time, as we know it, would cease to exist. Imagine a world where the past, present, and future are not linear but fluid, bending and warping with the speed at which we move. This is where Einstein's theory of relativity comes in. Einstein revolutionized our understanding of time and space, showing us that they are interconnected in ways we could never have imagined. It states that time is not absolute, it is relative. This means that time can stretch and contract depending on how fast you are moving relative to something else. It's like saying that a second is not always a second. The faster you travel, the more time dilates, making seconds stretch into minutes and minutes into hours. The faster you move, the slower time goes for you relative to someone standing still. This phenomenon has been proven with precise atomic clocks on fast-moving jets and satellites. At the speed of light, time would essentially stop. For a photon traveling at light speed, time does not pass at all. You could travel for hundreds of years and not age a single day. This opens up fascinating possibilities for space travel and exploring distant galaxies. But to someone back on Earth, centuries would have passed. Your friends and family would have lived their lives, grown old and passed away while you remained unchanged. It's a mind-bending concept, but it's a consequence of the universe we live in, a universe governed by the laws of relativity. These laws challenge our very understanding of reality, pushing the boundaries of what we believe to be possible. Section 6. Beyond the horizon of light speed. Now, you might be thinking, can we actually travel at the speed of light? The honest answer is, we don't know. Einstein's equations tell us that an object with mass would require an infinite amount of energy to reach the speed of light. That seems like a pretty big roadblock, but who knows what the future holds? Maybe, just maybe, there are loopholes in the fabric of space-time, shortcuts that could allow us to bend the rules. Wormholes, warp drives, these are not just science fiction, they are areas of active scientific inquiry. Section 7. A universe of possibilities. The universe is a vast, mysterious place. The speed of light, once thought to be an unbreakable barrier, may one day be a mere stepping stone. And if we ever do figure out how to travel at such speeds, who knows what wonders we might find. New worlds, new civilizations, new understandings of the universe and our place within it. Thanks for watching. Don't forget to subscribe and like the video. The possibilities are as limitless as the universe itself.